Swayam Prabha. Digital India. Educated India.
Hello everyone. Now our present topic is the Noil theory. So, as we have discussed in the last session, the Noil extraction is the primary function of comber. So, here what we will discuss, we will try to understand the parameters on which the Noil percent depends and how to calculate approximately the Noil content, and related numericals we will be doing. So, Noil theory is proposed by Gegoff. So, according to that, so there the fiber diagram is typically fiber diagram we get, this is the shorter diagram, but in Gegoff's simplified theory it is assumed to be a triangular distribution. This is the assumption to actually use this triangle. So, because it will help in easy, actually geometrically we can calculate the approximate Noil percent. So, in this theory two types of feeds are being considered, that is backward feed. So, feed of the sheet lap sheet is done during the return of the nipper. So, backward feed we have discussed, and forward feed when the feeding is done during the forward movement of the nipper towards the detaching roller. So, the staple diagram I have shown. So, this is the typical staple diagram of cotton, and here it is assumed the diagram is this. Okay. Now, first we will discuss the Noil elimination with backward feed. So, backward feed means during the backward movement of the nipper assembly the feeding will take place. That means during the forward motion there won't be any feeding. Z is nipper, A is detaching roller, here A is detaching roller, B is the fiber fringe protruding from nippers, this is the total length of fiber fringe protruding from the nipper, E is the detachment setting, which is the minimum distance from the detaching roller and the nipper line. So, nipper moves up to this point. So, that is a minimum distance. During detaching step, now let us consider this, during the detaching steps nippers are located at the closest point. So, that is at this point when it is closest distance from the detaching roller. So, at this point detaching will start. Detaching roller draws off all fibers longer than E. So, what happened here, the detaching roller is there and this is the combed fringe here. So, any fiber longer than this length E length will be pulled off by the detaching roller, and fibers of length less than E and not gripped by the detaching roller. Now, let me draw. So, this here whatever fibers are gripped by the detaching roller will be taken away by the detaching roller, but if the fibers are not gripped, suppose one fiber, this fiber is not gripped by the detaching roller and it is less than E, what will happen? There will be, during detaching there will be a top comb here which will restrict the movement. So, fibers less than E, that means detachment setting and not gripped by the detaching roller, and it will be retained by the top comb. So, that will be retained by the top comb. Now, the staple diagram is here. So, where M is the maximum fiber length AC. So, M is the maximum fiber length. So, in this condition, in earlier condition, so anything less than E. So, E is the length Mn. So, anything less than E, that means M N B in this triangle. So, the any fiber less than E length will go to the comber noil, that is it will go to the noil because it will be restricted by the top comb, but anything fibers more than the Mn will go to the comber sliver. So, fibers in the left side of Mn line is assumed to be going to the comber sliver. So, now you can see here it is the backward feed. Okay. This in during this backward feed, when the nippers closing, that means it is moving backward, the feed takes place. So, the feed takes place, feed amount is S, S is the feed length per cycle amount of length feed, and K is the combing segment. E length was there projecting beyond the nip line, and S is additional fed during the backward movement because it is a backward feed. So, the total length of fiber fringe or fiber lap placed in front of the for cylinder comb for combing will be E plus S. E was there and S is additionally fed. So, effective length will be E plus S. Now, in the second condition, the E plus S length will be QR. QR is the length. Here then left side of QR, any fiber left side of QR or longer than QR will be going to the comb sliver, and any fiber shorter than QR should go to the any fiber shorter than the QR, that is that means E plus S should go to the comber noil and combed out by the cylinder comb. So, in this case we will see when the nippers are at the forward point and nippers are at the backward point, two conditions are there, one is E, another is E plus S. Now, if we take the midpoint, so midpoint of these two will be E plus S by 2, it is only difference of S. So, the midpoint here of difference, the OP is the E plus S by 2. Now, if we see here E plus S by 2, so nipper retracts towards the cylinder comb, the feed is taking place S, total projected length is E plus S. So, fibers shorter than E plus S are carried out to the noil by cylinder comb. So, fiber more than E plus S is supposed to go to the comb sliver. In the region Q, M, N, R, it is matter of choice, either it can go to the comber noil or it can be retained as a in the comb sliver. So, the mean line is taken, so E plus S by 2, and using the similar triangle ratio, the ratio of square of sides are there. So, we can see P percent is, if we see take the similar triangle. So, the noil percent will be OPB. So, OPB, what is OPB? OPB by ABC, ABC, ABC is the total weight, okay. And here the area ratio, okay, equal to OP square, OP square by AC square, AC square. So, the area, similar triangle area ratio is the ratio of the square of the side, that is the similar triangle property. So, if we area ratio is nothing but the it is proportional to the weight mass ratio. So, OPB by ABC multiplied by 100 is the percentage of noil, which is nothing but OP square by AC square and multiplied by 100. OP means OP E plus S by 2, E plus S by 2 square by M square, M means the maximum fiber length, that is AC, and this is the noil percent for the backward feed. Now, if we see the forward feed, so noil percent increases, here noil percent increases as the feed distance increases. In case of backward feed, if we increase the feed per cycle, the noil percent will increase. Now, in case of forward feed, what happened after the detaching taking place? So, if whatever fiber more than length E goes to the comber sliver. So, here any fiber more than E that goes to the detaching comber sliver, that is true for both backward and forward. As there is no feed during the return, there is no feed. That means effectively the length E will be presented to the cylinder comb. In earlier case, length E plus S was presented. Here length E will be presented to the cylinder comb, and any fiber less than E will go into the comber noil. That means, here QRB, this zone will go to the cylinder comb by comber noil by the cylinder comb, and no feed during return. So, that is why E is being presented. Now, while forward motion, feed occurs during the subsequent forward stroke by S. S is the feed length, Now, here what happened? Feeding has taken place. So, this is the lap and here total length is E, and whatever the fibers were there, that is E is there and S is extra lap fed, and this was there was E, this is E part, E was there the red. So, additional S will of the previously that is the combed fringe will enter into the action of the detaching roller with, but remaining portion will be E minus S. E minus S is there, this is the lap portion. So, only E minus S of the combed fringe is under the control of the detaching roller. That means, when the top comb comes here, any fiber less than E minus S will go to the comber noil, because S amount which is combed already by bottom comb, it is not, or cylinder comb is not coming into action of the top comb. Only top comb takes care of the fiber length E minus S, and this remaining this lap, from lap fibers will not be coming, because it will be simply pulled, the fringe portion will be simply pulled from the lap. Okay. So, the effectively its E minus S less than E minus S fibers will be going to the comber noil. So, detaching roller should take all the fibers longer than E, but as S distance move forward, the effective length become E minus S. So, more amount of cylinder combed fiber come under the grip of the detaching roller. So, fiber length E minus S is going to the combed sliver, okay, only combed portion, and similarly we can get the Noil percent here, and taking the mean value E minus S by 2. So, Noil percent for forward feed will be E minus S by 2 square by m square multiplied by 100. So, from there what we can observe, in forward feeding the Noil percent is less than that of backward feeding with the same setting, E and S, M are being same. So, same fiber, if we use the backward feeding, the Noil percent will be improved, will be more. So, for better quality product, if we want to have more Noil to come out from the fiber, so we use backward feed, and for forward feed, this is the quality requirement is not that stringent. So, we can use the forward feed mechanism. The quality, shorter the E minus S passing into the comber, that is okay, S increases, if S increases, Noil percent reduces. So, if we increase the feed length, the Noil percent increases, reduces. Typical value of E is around 50 mm, 15 nm, and the feed length is typically around 5 mm. So, 5 to 6 mm. So, type of feed, this is the forward feed. So, forward feed, higher production, because lesser amount of Noil percent. So, productivity becomes more, quality requirement is not stringent because more short fiber goes to the comber sliver mainly for upgrading. So, if we want to upgrade not the full comb, it is called half combing, then we can use the forward feed. Noil percent is little bit in lower side 5 to 12%, and the backward feed or concurrent feed counter feed it is a E plus S by 2 square by m square multiplied by 100. So, where we require high quality demand. So, we need to extract more short fibers. So, here we are not actually taking any chance, short fiber should not be there. So, backward feed is required. So, here Noil percent is little bit higher side. The feed is usually no longer in use in modern high production. So, this because here main problem is that high Noil percent. So, this type of feed we do not use. Here forward feed is used with a lower Noil percent, but the total setting and vibration and other parameters are improved. So, the difference is not too much even if the Noil percent is less. So, the influencing parameters on Noil percent you can see as E increases for both the cases, the Noil percent increases. The closest distance that is E is the closest distance between the bite of nippers and nip line. Okay. As this E increases, the Noil percent increases. Normal range is 15 to 25 mm and points on combs. So, point density and finer comb per material. So, point density is increasing. So, it increases the Noil percent. Sawtooth comb is used for cylinder comb, more robust in place of needle comb for high speed comber. Top comb needles are flattened, that already been discussed. So, number of needle per centimeter, that needle density, production rate increases and Noil percent increases. Now, based on this theory, Noil theory, we will do some numerical. Now, let us discuss a numerical first. Numerical in a rectilinear cotton comber processing cotton with 40 millimeter longest fiber length, the detachment setting and the feed length per comb cycle is given 15 millimeter and 5 millimeter respectively. Calculate the change in Noil percent when the type of feed is changed from forward feed to backward feed. So, forward feed it was running and we are changing it to backward feed. So, we have to calculate the approximate change in Noil percent. So, first we will calculate the Noil percent for forward feed with the given setting and then backward feed, and we will change the difference. See the calculate the difference. So, M is given 40, E 15 and S 5. So, for backward feed, the formula is E plus S by 2 square by m square multiplied by 100. So, backward feed the Noil percent is 19.14%, and for forward feed it is E minus S by 2 square, okay, divided by m square multiplied by 100. So, as per this formula, so we are using E as 15 and S by 2 2.5, this becomes 9.76. So, the difference would be 9.38. So, from counter feed, the backward feed to forward feed, we will see that the change becomes 9.38%. So, simply by changing the feed type of feed, we can change the Noil percent typically around say 10% with the given settings. Now, the next numerical, a rectilinear cotton comber processing cotton with long staple length and a triangular fiber length distribution. So, that is as per Gegop theory. What will be the approximate feed length per combing cycle if the percentage change of Noil percent when the type of feed is changed from the backward feed to forward feed becomes 50% with the detachment setting 15 millimeter. So, what we have to calculate the approximate feed length, S has to be calculated, E is given as 15 millimeter, and from the type of feed is changed from the backward feed to forward feed. So, it becomes 50%, the Noil percent change in Noil percent will be 15%, 50%. Now, let us see. So, at backward feed, this is the relationship as we know, and for forward feed the relationship is given. So, percent change in Noil percent is 50%, that means E 15 and NF NB minus NF by NB multiplied by 100 is 50%. So, NB is E plus S by 2 square minus E minus S by 2 square divided by NB E plus S by 2 square multiplied by 100 is equal to 50. Now, solving this equation, E square plus S square by 4 E multiplied by S. So, by rearranging this equation, what we are getting, it is equal to 0.5 E plus S by 2 square, okay, the left hand side. So, 2 E s, so E s will be there. So, this is cancelled out, 2 E s equal to 0.5 E plus E square plus S square by 4 plus E s, okay. So, rearranging this equation, what we get, 4 E square plus S square minus 12 E s. So, from this equation, as we know, E is value is given, 15 is given. So, we get the relationship S square minus 180 S plus 900. So, this is the relationship and this is the equation, and this equation if we solve, we will have two values of S. So, these are the two values. So, 180 plus minus under root 32400 minus 3600 by 2. This is now getting the value. So, S cannot be a negative value. So, we are getting the, and S cannot be too high. Here if we see the S will be too high for, if we assume S as the plus signal, if we take that S cannot be, it is not possible. So, we take the negative value to have S value 5.15. 5.15 is the feed length. Feed length cannot be very high. So, this is the feed length. So, 5.15 which is been asked. Now, to calculate the productivity of comber, so this is the numerical. Following are the technical data related to rectilinear cotton combing. So, speed is 300 nips per minute, number of heads are given 8, linear density of feed lab is 60 kilotex, length of lab fed is 5 millimeter per nip, that is feed length, tension draft during lab feed is 1.05, running efficiency is 95% and Noil extraction 15%. Calculate the productivity. So, we know the comber production formula here, where N is the nips per minute is given, then lab feed per nip S is 5 which is given, and this 1000 is coming here to convert it to meter, and feed sheet is G is kilotex, and kilotex to tex we get 1000, and Noil percent is 15%, okay, and there 60 is for that hour, and number of combing head H, and E is the efficiency. So, if we calculate, and total tension draft is given A equal to 1.05, and from this value we get the production. So, these are the production, this we are actually replacing all this value, actual value given, and here production we are getting 33.22 kg per hour. So, with this data we can calculate using this relationship. Now this numerical is Noil theory and productivity. We are merging these two concepts. So, here the data are almost same. So, a rectilinear cotton comber is producing cotton fiber with 38 millimeter longest fiber length in a triangular fiber length distribution. Calculate the approximate change in productivity in kg per hour when the type of feed is changed from forward feed to backward feed. As we have seen, forward feed and backward feed, it affects the Noil percent. So, here the Noil percent will be different and rest other parameters will be same as earlier numerical. So, M 38, E 15, S 6, let us calculate the Noil percent. For backward feed it is 22.3343%, and forward feed it is 9.97%, and based on that the productivity will change. Now, the productivity for backward feed where we are using the Noil percent 22.43, it becomes 44.57 kg per hour, and productivity for forward feeding it will be 51.73 kg per hour. So, then these are the difference, for 57.73 minus 44.57. So, during the change of type of feed, the productivity is changed in this fashion. So, the total productivity is decreased by 7.16 kg per hour. The next numerical here, an 8 head comber is running at 300 nips per minute. The lap fed is 60 kilotex, Noil level is 20%. If the feed per nip is 7 millimeter, the production at 80% efficiency will be, so using the same relationship we get 38.7, where option C is correct. Now, another numerical for productivity, 8 head comber, it is running at 20% Noil extraction. Noil extraction is given, feed per nip is given 9 millimeter with the comber lap density 60 gram per meter. If the production is 40 kg at 80% efficiency, calculate the speed of comber in nips per minute. The same formula will be used. So, this is the production rate where the nips per minute is to be calculated. So, in we have to calculate here, the productivity is given. So, all the remaining data are given. So, here we can see the N is 241 nips per minute. So, in this way if we know the basic relationship, we can calculate any parameters. Now, another numerical, an 8 head rectilinear cotton comber running at 350 nips per minute speed with 95% efficiency is processing 63 kilotex comber lap from cotton of 838 millimeter longest fiber. So, running speed is given, 90% efficiency is given, and feed lap kilotex is given. Okay. Now, the diameter of detaching roller, so Noil theory and feed system. So, here this numerical is related with the feed system. Now, in addition to this, other information is given, that is the diameters of detaching roller, feed roller and cylinder comb. So, there what it is given 20 millimeter, 30 millimeter and 150 millimeter respectively. The comber is running with forward feed and 18 detachment setting. So, E is 18 with 20 teeth in the ratchet wheel. That means, one ratchet wheel, one teeth will actually, for one tooth there will be movement. Okay. For one tooth there will be movement for the per feed cycle, the one tooth movement will be there. Okay. What will be the detachment setting if you want to have same level of Noil with backward feed at 30 teeth at the feed roller ratchet wheel. So, initially it was 20 teeth with the forward feed 20 teeth. Okay. But here what we are doing, we want to have same Noil percent and we want to have detachment setting for forward feed. Okay. So, this for backward feed, this is the forward feed is 18 millimeter. So, we want to calculate the detachment setting, but the condition is that Noil percent is same. Now, let us see. So, case 1, that is per cycle the feed will be pi d circumference divided by 20. 20 is the number of teeth of the ratchet. So, that is 4.71 millimeter and its a forward feed E is given. So, we can calculate the Noil percent. So, Noil percent is 16.95%, that is Noil percent. Now, the same Noil percent will be there for backward feed with 30 ratchet wheel and E we have to calculate. So, the new this is simple again. So, 30 is the ratchet wheel. So, feed length has reduced to 3.14. So, E has to be calculated and which is given, it was the same Noil percent 16.95 to that of the forward feed. So, E plus 3.14 by 2 square divided by 38 square, the fiber maximum fiber length is 38. So, after solving this equation, so we get E value is 14.07, which is the answer. Next, Noil theory and feed system combination. So, these are the data given. A rectilinear cotton comber is producing cotton fiber with 38 millimeter longest fiber length and a rectangular fiber length distribution. Calculate the approximate change in productivity, that is in kg per hour, when the type of feed and the number of teeth in the ratchet wheel are changed from 20 backward, sorry 20 forward 22 to backward 16. Initially forward feed 22 teeth to backward feed 16 teeth, and with all this parameter we want to calculate the change in productivity. So, this is given here, number of teeth 22. So, we can calculate detaching roller is diameter is that. So, teeth and diameter is 16, detachment rating is 15 is given. So, diameter of feed roller is 30. So, feet per knee becomes 4.28 for forward feed, okay, with 22 teeth, and Noil percent is 11.5%. So, here basically the Noil percent will be different because number of teeth affect the feed. Okay. So, production in case 1, as it is forward feed, it will be 36.29. Now, in case 2 backward feed, the number of teeth was 16 and feed roller diameter is 30 mm. So, feed will be 5.89 millimeter and Noil percent is 22.30% and production we can calculate, it is a 43.82 kg per hour. So, the change in productivity will be 7.53. So, all these combinations we can do, but what we have done, we have tried to understand the Noil extraction, and it basically is dependent on the detachment setting and feed length and also fiber length. So, here the last numerical is a Noil theory, feed system and productivity. These are combined. So, a rectilinear cotton comber is processing 63 tex cotton comber lab with 38 millimeter longest fiber and triangular distribution. Calculate the detachment setting E, that this will be E, we have to calculate if the change in productivity becomes 7 when the type of feed is changed from forward feed to backward feed. Technical data are given: diameter of feed roller 32 mm, speed of comber 350 nips per minute, number of head is given, tension draft is given, number of teeth in the feed roller ratchet is 16 and running efficiency is given. So, what we do, we calculate the feed length will be same because the diameter and all ratchet wheel teeth is same. So, here forward feed we get the Noil percent N1. So, N2, this is the Noil percent for the backward feed, and production in forward feed is this. So, these are all the constant. So, 0.6014 multiplied by 1 minus N1 kg per hour. For backward feed 0.6014 100 minus N2 kg per hour. So, the change is in production kg per hour is 7 as it is given. So, N2 minus N1 is 11.64. So, this is the Noil percent N2 and N1, it is 11.64%. So, from this equation, so this is for E plus 3.14 square by 38 square multiplied by 100 is its N2, this is N2 and here it is a N1. So, this as we have calculated it is 11.64. So, we get this relationship, this equation, and from this equation we are getting value of E becomes 13.38 millimeter. That is what it was asked. So, the detachment setting is 13.38 millimeter. So, based on the Noil theory we can solve different types of numerical related to productivity, related to feed system. Okay. So, we have come close to this section. So, thank you. In the next section we will continue with the comber and we will discuss the mechanism, that is a differential gear mechanism in the detaching roller, how the detaching roller gets motion. Till then, thank you.